Two pipes A and B can fill a tank in 20 and 30 minutes respectively. If both the pipes are used together, then how long will it take to fill the tank? So A fills the tank completely in 20 minutes. So we can now write that part filled by A in 1 minute will be equals to 1 by 20. In similar way, B can fill the tank completely in 30 minutes. So part filled by B in 1 minute is equals to 1 by 30, isn't it? Now A and B operate together, that is, they both fill in the tank together. So part filled by both operating together in 1 minute will be equals to the addition of their individual parts in 1 minute. So this is equals to 1 by 20 plus 1 by 30, and that's going to be 1 by 12. So 1 by 12 parts of the tank is filled in 1 minute. How long will it take to completely fill the tank? Well, just the reciprocal of the part filled in 1 minute. So 12 minutes is the time that is going to take for A and B to completely fill the tank. So option A is the correct answer for us. A cistern can be filled by a tap in 4 hours, while it can be emptied by another tap in 9 hours. If both the taps are opened simultaneously, then how much time is needed to fill the cistern? Well, let us consider that the filling tap is A. So the part filled by A in 1 hour will be equal to, the tap fills the tank completely in 4 hours. So part filled in 1 hour will be equals to 1 by 4. Now there is another tap, let us name it as B, which empties the tank. So this tap empties the tank in 9 hours. So in 1 hour, the part emptied by B will be equal to 1 by 9. Now the rate of filling is much more than the rate of emptying. How do you know that? Well, it takes less time to fill the tank than to empty the tank. So the net effect is that the tank is getting filled even if both the taps are open. So the net part filled in 1 hour will be equals to the part filled in by A in 1 hour, that is 1 by 4, minus the part emptied by B in 1 hour, that's 1 by 9. And that is equals to, if you solve it, you'll get 5 by 36. Now you need to calculate how much time is needed to fill the cistern. Well, 5 by 36 of the tank is filled in 1 hour. So what is the time? Let it be x, in which the tank is full. The tank is full when it is 1, right? So this is the direct proportion. We can take the ratio and equate. So x is equal to basically the reciprocal of the part filled in 1 hour. So that's 36 by 5, and that is equals to 7.2 hours. So the answer is option D. A tap can fill a tank in 6 hours. After half the tank is filled, 3 more similar taps are opened. What is the total time taken to fill the tank completely? Well, let us draw the situation now. So this is the tank. Half of the tank is filled in by 1 tap, and the other half will be filled in by 4 taps, isn't it? Because it is said that after the half of the tank is filled, another 3 of the similar type of taps are opened. So the remaining half will be filled in by 4 taps. Now it is given that the tap can fill a tank in 6 hours. So half of the tank will be filled in 3 hours. Now we have to calculate the total time that is taken to completely fill the tank. Now to do that, we will first find out this time to fill half of the tank by 4 taps. Now let us find out the part filled by 4 taps in 1 hour. Then we can calculate the total time taken to fill the half of the tank. Well, we have 4 taps, so 4 times the part filled by 1 tap in 1 hour. Well, 1 tap can take 6 hours to fill the tank, so in 1 hour it fills 1/6 of the tank. So that's 2/3 of the part is filled by 4 taps in 1 hour. Now you can write it as you have part filled, which is 2 by 3. The time taken is 1 hour. Now you want the time taken to fill half of the tank. So 1 by 2. This is a direct proportion. The more the part filled, the more the time will be taken. So this is, we can equate these two ratios. On the left hand side I can write this 2 goes up, 3 comes down. So 4 by 3 is equals to 1 by x. Therefore x is equals to 3 by 4. So 3 by 4 hours are taken to fill half of the tank. Now how much is 3/4 of an hour? Well, it is 45 minutes. So the total time taken to fill the tank completely is this 3 hours plus the time taken to fill the rest of the tank by 4 times. So 3 hours 45 minutes is the total time taken. So option B is the correct answer. Pipe A can fill a tank in 5 hours, pipe B in 10 hours, and pipe C in 30 hours. If all the pipes are open, in how many hours will the tank be filled? Well, let us calculate the amount filled when all of these pipes are open for 1 hour. So this will be equals to the part filled by A in 1 hour, that's 1 by 5, plus the part filled by B in 1 hour, that's 1 by 10, plus the part filled by C in 1 hour, that's 1 by 30. So you have the LCM as 30, you have 5 times 6 is 30, so 6 plus 10 times 3 is 30, so 3 plus 1, and that's 6 plus 4 is 10, so 10 by 30, and that is 1 by 3. So 1/3 of the part is filled by A, B and C when they are open. All of them are open in 1 hour. So what is the total time taken to fill the tank? Well, just the reciprocal of this term, that's 3 hours. So 3 hours is the time taken. Option C is the correct answer.